So now we're going to be looking at horizontal asymptotes, and we're going to be looking at three different cases. So let's take the first case. Case number 1. Now, please have the notes out, print the notes off, or whichever. I'm going to be reading the English instructions from the notes. So, case 1. Y equals x cubed over x. So, x on the bottom has an exponent of 1. So, from the notes, if the exponent of x is higher on the top than the bottom, so because 3 is greater than 1, that means that the exponent on the top is greater than the exponent on the bottom, which means that the horizontal asymptote is none. Feel free to graph it on the graphing calculator. That actually simplifies to be x squared, but we have a denominator, so x can't equal 0. It actually looks like a little graph with a hole here and our regular parabola. We're going to talk about holes a little bit later. But outside of that, if the exponent of x is higher on the top than on the bottom, then we have no horizontal asymptote. Let's take a look at case number 2. So, case number 2, from the English instructions, if the exponent of x is higher on the bottom, like y equals x over x squared, well, x is to the 1 on the top, so 2 is greater than 1. So 2 is greater than 1. So again, if the exponent of x is higher on the bottom than on the top, the horizontal asymptote is y equals 0. Now this simplifies to be 1 over x, and now we've seen from the last sections that the graph looks like that. And as you can clearly see, we have a horizontal asymptote at y equals 0. Now, what if I decide to take that same thing, y equals 1 over x. Again, keep in mind, the one I gave you before, x over x squared, I just wanted to introduce that to really get the point across. If the exponent of x is higher on the top than on the bottom. Now, this y equals 1 over x, we have an exponent of 1 on the bottom. But what is the exponent of x on the top? Well, it's actually 1 x to the 0. Now, x to the 0 is equal to 1, which means that goes away. So, we know that 1 is greater than 0. So we would have a horizontal asymptote at y equals 0. But let's take a look at the same question, but let's shift that graph up 1. So we're going to go a little bit more into transformations in the next section, but we should know that this 1 simply does a vertical translation up positive 1, which means that we take our old graph and we just simply shift it up 1. So if case 2 has a transformation off to the right, that is the horizontal asymptote. HA, y equals that number. So if we draw that graph, it looks incredibly similar to our last one, but we're shifting it up 1. So where we used to have a horizontal asymptote at y equals 0, it's now shifted up 1. So we have a horizontal asymptote at that number. And then we can simply draw in our memorized graph close to the asymptote, close to the horizontal asymptote, close to the axis, close to the horizontal asymptote. So be really careful with these different forms because each individual case has a modified form. So again, case 1, horizontal asymptote, none. Now, a little bit later in 9.6, we're going to get to slant asymptotes. Now, if case 1 long division can be done to, we may have a slant. So I'm just going to put that off to the right. A slant asymptote. Question mark. Maybe. This one obviously doesn't. Case 2, the initial case, if the exponent of x is higher on the bottom, y equals 0. And if we transform that graph up 1, for example, the horizontal asymptote is y equals that number. So now we're going to have one more case. Case 3. So, case 3, if you read from the notes, if the exponent of x is the same on the top and the bottom. So let's take y equals 4x squared over 1x squared plus 2. Well, I have x squared on the top and I have x squared on the bottom, meaning that the exponent of x on the top and the bottom is equal to each other. And if the exponent of x is the same on the top and the bottom, the horizontal asymptote is y equals the fraction of the coefficients of the x squared term, 4 over 1, or simply 4. Now, this graph would be difficult to draw. You would have to use the table of values and whatnot. But if I just sketch a graph, y equals 4 is the horizontal line. Let's call it 4. And we're going to have a horizontal dotted line as our horizontal asymptote. And again, graph it with the table of values, but I will just quickly graph that here. And you can see that in the notes or on your graphing calculator. So again, case 3 modified. What if we have y equals 4x squared over 1x squared plus 2? The same question as before, but now we move this graph up 1. Well, we used to have a horizontal asymptote at y equals 4. But this 1 is a vertical translation up 1, which means that we simply have to add 1 to our horizontal asymptote to get y equals 5. So we can simply take our old graph and shift it up 1. Where it used to have a horizontal asymptote at 4, now it's at 5. And then the same old graph just gets shifted up 1. So again, you can graph the rest of that with a table of values or your graphing calculator. So let's review. Case 1, if the exponent of x is higher on the top than on the bottom, there is no horizontal asymptote, but there might be a slant. Case 2, if the exponent of x is higher on the bottom, y equals 0. If that graph has a vertical translation up 1, then we simply move the horizontal asymptote from y equals 0 up 1 to y equals 1. Case 3, if the exponent is the same on the top and the bottom, 2 and 2, y equals the fraction of the coefficients of the x squared terms, 4 over 1. If case 3 is modified with a vertical translation up 1, Then the horizontal translation up 1, the vertical translation up 1 makes the new horizontal asymptote up 1 from what it used to be at 4 to be at y equals 5.